It's 2112. What about Latin?
Do that?
Okay.
When I was sick, it was so good.
All right. Stop talking. Let's start reviewing what we've done. Now, the book starts out talking about molecules, organic molecules and such. And the first chapter is just kind of talking about what science is, and how investigations are done, and hypotheses and theories and stuff. I'm not going to review that. The second chapter starts out with basic chemistry, which you should already know because you took a year of chemistry. And I'm not going to review much of that. But I will talk about organic molecules briefly. Because organic molecules make living things. What's the deal with organic molecules?
Carbon and hydrogen.
Basically, all organic molecules, I have nothing to write with. All organic molecules are based on carbon. Why is carbon important?
It's 4 electrons.
It has 4 electrons in its outer level. That means it can bond to 4 different things. That means you can make these huge molecules with it. By attaching one carbon to another, to another, to another, you can make these long molecules. It's the only atom that does this. There's no other atom that can bond to that many things. So that's why we think if there's life anywhere, it ought to be carbon-based.
Yeah, baby. Yeah.
Wait, that's the wrong chapter.
Oh, well.
Chapter 3 is organic molecules.
Oh, so we're starting.
Behave.
Yeah, this is chapter 3, sorry.
So we're not gonna do anything from 1 or 2.
Nope. That's what I was just saying.
Oh, good.
Thank you. So look, here's carbon after carbon hooked together in a string. Sometimes the string of carbons can curl around on itself and form rings. And if you throw in some hydrogens and oxygens, you now have a ring of carbon. We call that a carbohydrate. Remember this? A ring of carbons. A single ring carbohydrate is a monosaccharide. Remember glucose, fructose, ribose,
So
deoxyribose? Those are single ring monosaccharides. Yes.
So glucose is not a sugar, is it?
Glucose is a sugar because all these carbohydrates are also called sugars.
Okay. Good.
What are these used for? What is glucose used for in a cell?
Make ATP.
It's used for energy. These bonds between the carbons contain energy. It takes energy to make 2 atoms bond together. So if you take this molecule and tear apart all the bonds, you get the energy back out. This is why you need to eat sugars. Because they go to your cells and your cells can use them for energy. So glucose, fructose, ribose, those are single ring. We call them monosaccharides. If there's 2 rings together, what do we call them?
Disaccharide.
Disaccharides. Sucrose, maltose, lactose. Those are disaccharides. Monosaccharides and disaccharides, if you put them on your tongue, they taste sweet.
What kind are they? Glucose, fructose, and what?
Ribose and deoxyribose are monosaccharides.
Glucose, fructose, ribose, deoxyribose.
Those are monosaccharides.
Disaccharide is sucrose, maltose, and lactose.
What if we hook a bunch of them together?
Polysaccharides.
Polysaccharides. Those get to be very long molecules. Remember those polysaccharides? I got some good pictures of polysaccharides up here.
Are we going to need to know?
Look, ooh, there's starch. Y'all ever seen starch before? Look at that. That's a polysaccharide. Can you tell there's many of these things hooked together? And just think if you ate a molecule like this. These long chains would get in your stomach and intestine, and they would be digested. And these things would be torn off one by one. So you eat starch, you end up with sugar. That's why starches give you energy. Somebody said something? I was asking a question? Yeah.
You said the amino acid chains would be really
That's
important.
protein.
Groups would be. Okay.
It's proteins. We're going to get to those. Okay? Good with carbohydrates? They're also used to build, sometimes carbohydrates are used to build structure. The cell wall of plant cells and fungi are made of this. Y'all ever heard of this before? Cellulose. You're writing on cellulose right now. Cellulose is a structural carbohydrate with many of these rings attached together in a long chain. Your paper is made of sugar, y'all. Sugar molecules attached together.
But we can't.
If you could digest this, you could eat paper. Because we don't have the enzymes to digest them in our body.
That's a stupid video.
Termites do. It's a stupid video about cellulose. Showing a lady with a cellulose or some kind of dress and she's dancing. What about fats, lipids? Remember what a fat is made of?
Fatty acids and glycerol.
Fatty acid chains
Fatty acid chains.
and glycerol.
Glycerol.
Glycerol is a group of 3 carbons and some OHs hanging up. And the fatty acid chains are just carbon after carbon after carbon bonded with hydrogens in long chains. Remember these molecules? That's a fat, a lipid, and that stores sugars. You see, you can take one of these monosaccharides, which is carbons in a ring, and you can break one of the bonds and straighten that out. And now you got one of these. Maybe straighten that thing out and hook a couple of these together in a long chain, and you got one of these. Then you can hook it onto a glycerol, and now you got fat. Can you get fat from eating sugar?
Yes.
Heck yeah, you can. Go try it tonight. Just eat cotton candy all night, as long as you can. Then keep doing that for months. You'll get huge. Because you'll store it. This is stored. That's what lipids are. They're stored sugars. Now, sometimes the fatty acid chain has a little kink in it. You know what we call that?
Saturated.
We call that unsaturated. That's what's
Unsaturated.
pointing here. And sometimes it's a straight chain. That's called saturated. Saturated fats tend to be bad for you because they can build up in your arteries and clog your arteries.
Is there a way of getting them out?
Not eat, and your body will remove the stored fat and use it for energy. Lose weight.
But what's straight? Saturated?
Yes. Saturated is straight, unsaturated is
That's what the book calls it, kink.
Real quick.
A kink, yeah.
If a really fat person were to just stop eating for like a week, but they would drink water, obviously stay alive.
Probably need vitamins too.
Vitamins.
Yeah,
Okay.
keep their enzymes running.
Yeah. Would it just go away?
They lose
slowly?
weight? Yeah.
What about the
Lose
stuff?
weight,
They would be able
dieting
They would be able to survive because it's using the fat stored.
for energy.
So even the stuff inside of your arteries or whatever, that'll disappear?
Yeah. That'll be used for energy.
So
That's what it is. It's storing fat. You've run out of room under your skin, so it starts storing it in your arteries.
So if you just got really fat and then carried around some vitamins and water, just ate
Yeah.
that for a while.
But then
Have
when
you ever seen that show? Biggest Loser. That's exactly what they do. And if you're working out while you're doing it, you lose it even faster. Here's a protein, y'all. It's a chain of amino acids. Y'all remember proteins? Do you remember what an amino acid is? These are all amino acids. You need to know the structure of an amino acid. It's got an amino group. It's got the acid group, the carboxyl group on the other side. And it's got the R group,
Okay.
the variable group hanging down in the middle.
And all amino acid chains or groups have a carboxyl.
All amino acids have an amino and a carboxyl, and the variable group in the middle.
But there's 20 R groups.
There's 20 different R groups. They show them up there on the board, on the screen. So you hook these amino acids together in a long chain, you see. And this is we call this the primary structure of a protein. Remember that? Primary? Do you remember it can kind of coil into a secondary structure?
The alpha helix.
An alpha helix, very good. And then a tertiary structure, a beta sheet. Remember that?
So secondary would be
Quaternary.
Alpha helix and beta
Tertiary
sheets.
and then quaternary.
And then tertiary is when all that. Well, why is this folding at all? Why not it just say stay straight? Why does it fold?
Because it
Space.
saves room.
Transfer to different places.
Yo, the little R groups attach to one another. They're magnetic.
Makes it stronger.
Some of them are positively charged, some of them are negatively charged, and they'll attach. So
So-
they'll bond to one another, and so this all coil up and curl up to its final protein structure. Proteins are the workers of the cell. They're also called enzymes, remember? So a protein can come up and it can take things and put them together and put things apart. The rise and fall of organized labor, it can just tear that up because it's not needed right now. I'm joking. A little joke there. Enzymes. Remember enzymes?
And then peptide bonds.
Peptide bonds hold the amino acids together. Y'all remember how proteins are made? By the DNA information in the ribosome. Very good, Steffi. We'll continue that discussion tomorrow. Start reviewing. Do what you can. If you want to go to Books a Million,